Welcome back. In this video, we're going to work on addition and subtraction of fractions. Addition and subtraction of fractions, often people will find this trickier than doing multiplication with fractions just because of the need to have a like or common denominator when you're doing it. So that's the main issue. So the rule for adding and subtracting fractions, if you have a over c and you're adding to it b over c, notice the bottoms are the same, that you keep the same denominator and then either add or subtract the numerators, depending on, of course, whether you're adding or subtracting. So that's the rules basically for adding, provided, of course, the denominators match. You add the numerators and keep the same denominator. For subtracting, you keep the same denominator and subtract the numerators. Okay, so let's try it. So first, we'll have x over 4 plus 3 over 4. We're going to keep the 4 on the bottom, and the top is just x plus 3. Okay, so that's it. In the next one, we have negative 19/28, and we're going to subtract from it 7/28. So we'll keep that same denominator of 28. And then in the numerator, the top, we'll have negative 19 minus 7. So negative 19 minus 7 is negative 26. Negative 26/28. Don't forget when you're doing addition and subtraction of fractions to always look out for opportunities where you can simplify. Here, 26 and 28 are both even, so we can divide the numerator and denominator by 2 to get negative 13/14. And that will be our final answer. So in here, we've seen that we basically just need the numerator and denominator, or the denominators to match, and then we combine the numerators as written. Okay, so let's try the next one next. Here we have negative 8 over y minus 5 over y. And so the final answer here will be over y. We'll have negative 8 minus 5, and that's negative 13 over y. Okay, and that's the end of that. If the numerators, or sorry, if the denominators match, these are not too bad. If the denominators don't match, then our first step is going to be to make them match. Okay, before we do that, we have one more example. This one, we've got some ninths. We have negative 2/9 plus negative 4/9 minus 7/9. So we're combining up ninths. So we'll have negative 2/9 plus those negative 4/9 minus 7/9. Okay, now our answer here is going to be a ninths. Negative 2 plus negative 4 is negative 6. Negative 6 plus negative 7 is negative 13. So we have negative 13/9. Okay, if you were looking at that, by the way, and thinking about, should I turn that into a mixed number like negative 1 4/9? In general, you don't need to. The further you go into algebra, the less you're going to need mixed numbers. So we won't emphasize that here. Okay. All right. So then in order to work with or do addition and subtraction, the denominators have to be the same. So taking a look at 7/12 plus 11/15, we want to think about what the LCM, that is least common multiple of 12 and 15 is. That would be the smallest number that is a multiple of both 12 and 15. If you're looking at 12 and 15 and you think 3, you're thinking the greatest common factor, which is something else. We're looking for the smallest number that both 12 and 15 divide into, and that's going to be 60. It may take you a little time to get to that, and that's okay. I'll actually show you another way to do that, do this addition, which works even if you don't kind of instantly think about what the LCD is. So for 12 and 15, you did probably recognize that they do have that common factor of 3. So I'm going to go ahead and factor the two denominators here as we get started. So we have 7 over times 4 plus 11 over 3 times 5. So now, in order to make the denominators match, if they're going to match, they should have the same factors. So I can tell that both have a factor of 3. But the fraction on the left has a factor of 4 that is not present on the right-hand fraction, and the 5 that is on the right side is not present on the first fraction. So we're going to fix that by multiplying the numerator and denominator of each fraction by the required factor. So in the first fraction, we'll multiply the top and bottom by 5. In the second fraction, we'll multiply the top and bottom by 4. This ensures now that both fractions have factors of 3, 4, and 5. And now if you take a look and multiply out those denominators, 3 times 4 times 5 is in fact 60. So there is that. We'll have in the first fraction 35 sixtieths, in the second fraction 44 sixtieths. Now that both fractions are denominated in sixtieths, we can go ahead and combine their numerators. That is going to be 79 sixtieths. And there's our answer. Okay, so here we've inserted the missing factors wherever they were needed. Okay, let's try another one. We have 13 24ths minus 17 32nds. So for this one, again, if you think of what the LCD is, great. If not, we're going to take kind of a missing factor approach. I can take a look at 24 and 32, and I can see that both are divisible by like 4, 8, and 2. Usually it's helpful to think about whatever the biggest factor is that they have in common. And so that's going to be 8 here. 24 is 3 times 8. And 32 is 4 times 8. So now we can see that the first fraction has a denominator with a 3 and an 8 in it, but there's no 3 in the second fraction. On the other hand, the second fraction has a 4 in it that is not present in the first fraction. So we're going to go through and insert the required factors. So the first fraction needs a 4, and we'll have to put that into both the numerator and denominator, otherwise the value changes. The second fraction was missing the 3 in the bottom, so we're going to have to put the 3 in. So that will do it. So now our new denominator looks like it's going to be 96. So there's that. And then 13 times 4 is 52. And then 96 is for the second fraction. 17 times 3 is 51. 52 minus 51 is just 1. After all that, we'll just have 196. Okay. All right, next up, we have y over 6 plus 7 over 9. On this one, I can tell it's the number's a little smaller. It's a little easier for me to see that the LCD is going to be 18. 18 is 3 times 6 or 2 times 9. And so let's build up our fractions so that we have the correct denominator of 18. So 6 goes into 18 3 times, so we'll have to multiply the top by 3 also. That gives us 3y over 18. For 7/9, 9 goes into 18 2 times. We'll multiply the 7 on top also by 2, getting 14 8. As you recall from our earlier work with fractions, we can always double check by simplifying right here to ensure that we would simplify to the fraction we start with. We should end up with just 3y over 14 for our final answer. All right, let's try the next one next. So for the next one, we have 5x over 6 minus 3/10. So here we could find the LCD. The LCD is going to be 30. Okay, and again, if you didn't see that, we could take a common factors approach and recognize that the 6 and the 10 both have a factor of 2, and just partially factor those denominators. But here I can see that our LCD is going to be 30. We'll build up our fraction so that its denominators are 30. Okay, 6 goes into 35 times. We'll multiply the top by 5 also. That will give us 25x. Down below 10. Okay, 10 goes into 33 times. 3 times 3, 9. So 9/30ths. Okay, so now we'll keep that same denominator of 30ths and then subtract 25x minus 9. Okay, and that's how that will look. Once again, keeping the same denominator and then combining the numerators. Okay, So here's one for you to try. Take a minute, pause the video, and try it yourself, and then restart the video and see how you did. All right, so while you were away, I fixed the 5 so it looked less like a 6. Okay, so here 5 and 6 have a least common denominator of 30. So we're going to multiply the first fractions top and bottom by a 6 so that our new denominator can be 30. The second fraction will multiply the top and bottom by a 5 so that the denominator is 30. This will give us 24k minus 5 in the top and 30 in the bottom. Okay, and that will do it for that problem. We can use some of what we've learned to help us in simplifying expressions that have fractions where we need to use the order of operations. So for this first example, we'll have 1/3 squared in the numerator, and then 2 cubed plus 2 in the denominator. So here the fraction bar strongly separates the numerator from the denominator. And so we can do the numerator first. 1/3 squared is 1/3 times 1/3. And 1/3 times 1/3 is 1/9. Down below, we have 2/3. It's 2 cubed plus 2. 2 cubed is 8. And then 2 is 2. This will give us 1/9 divided by 10. By the way, as a reminder, when you're writing fractions, you want to pay attention to the lengths of your fraction bars. I want to make sure when I write this that it really looks like 1/9 divided by 10. If I'm not careful about it, then you don't know if I am saying 1/9 divided by 10 or 1 divided by 9/10. And they're different. Okay, so in order to be sure about it, let's go ahead and make that fraction bar good and long so everyone knows that it's 1/9 divided by 10. Okay, so our 1/9 divided by 10 is the same as 1/9 times 1/10 or 1/90. Okay. In the next example, we actually have some fractions to add. So let's do that. So in the numerator, we're going to get a common denominator for the halves and the thirds. That will be sixths. So 1/2, in order to build that to sixths, we'll multiply the top and bottom by 3. For 2/3, we'll multiply the top and bottom by 2. And we'll finish that in the next step. Down below, we've got 3/4 and 1/6. The multiple or common denominator for fourths and sixths will be 12ths. And in order to build up 3/4 into 12ths, we'll need to multiply the numerator and denominator by 3. For 1/6, we'll need to multiply the numerator and denominator by 2. So now, starting to simplify some of this, 1/2 times 3/3, that will be 3/6. And then on the right, we'll have 4/6. Okay, down below, we'll have 9/12. And then that's a subtraction, actually. We'll have minus 2/12. Okay, up top now, we have 3/6 plus 4/6 makes 7/6. And then down below, 9/12 minus 2/12 is 7/12. Okay, so now we're taking 7/6 and we're dividing it by 7/12. To carry out our division of the two fractions, we'll keep the same first fraction, turn the division to multiplication, and turn our 7/12 into 12/7. Here we're able to divide out those two 7s. That will leave us 12 divided by 6, which is 2. Okay, so that's kind of cute. I didn't think that all that stuff with the fractions was going to turn out into a nice whole number, but it did. So that's pretty great. Okay, last part, and then we're all done. This last piece has to do with evaluating expressions with a variable present. So here's how this goes. We're going to replace each variable with its value and then compute according to order of operations. So for our negative 1/2 minus y, we'll replace the y by negative 1/4, being cautious about all those minus signs that are in there. The original expression had a minus sign in it, and then that is replicated here. Our y was itself negative, which gave us yet another minus sign. So we'll be careful about those. Negative 1/2 plus 1/4. So here we're combining our two fractions. We need to get the denominators the same. Halves to turn that into fourths. We'll multiply the top and bottom by 2. This will give us negative 2/4 plus 1/4. Now that the denominators match, we're able to combine the numerators, get negative 1/4 for our final answer. Okay. All right, so next up, we're going to evaluate 3ab squared, where a is negative 2/3 and b is negative 1/2. You may want to pause the video, try this one, and then restart it and see how you did. So meanwhile, we will continue. We have 3. A was negative 2/3 and b was negative 1/2. Okay, so then we need to be careful about this. Remember that we can always view our whole number of 3 as a fraction if we want. We can look at that as 3 divided by 1. We have negative 2/3 and we have negative 1/2. Remember that for multiplication, you do not need to get a common denominator. In fact, usually it's a bad idea because it makes the numbers unnecessarily large. So we won't bother. With that, we do get to divide out common factors of 3 here, and then also a common factor of negative 2. Okay, so then what that leaves us with, looking across the top, we will have negative 1 in the numerator and then a 1 in the denominator, so just negative 1 after all that. Okay. Last example, we're going to evaluate a plus b over c for some given values of a, b, and c. So a plus b over c, we're going to replace the a by negative 8, the b by negative 7, and the c by 6. Negative 8 plus negative 7 is negative 15, and 6 is 6. Okay, don't forget to simplify your negative 15 over 6. Here there is a common factor of 3 in the numerator and denominator. And so we're going to divide out that common factor of 3. That will give us negative 5/2. Okay, that takes us to the end of our look at adding and subtracting fractions. Remember that the key idea is that you need to make sure that the bottoms match, and the easiest way to do that is by multiplying the numerator and denominator of the fractions by whatever factors are missing in order to make those denominators match. Once they do match, you keep the same denominator and combine the numerators using either addition or subtraction, whichever it is. Okay, that takes us to the end of this section. Let me know if you have any questions, and have a great day.